Okay. Welcome to a recorded and uploaded episode of Elliot Astro-Imaging. Yes, so the third time is a charm. So we tried to do it the first 2 times on YouTube and it did not work. So we are going to upload this. So for all the viewers out there, welcome. Sorry there is no interactive content. I'm sorry. But hey, we got to get this out somehow, and I figured we might as well do it right. And we're going to go it as quickly as possible, so this way we can keep your attention span. Because the last thing I want is to keep this as long as possible and bore the living heck out of you guys. I do not want that to happen. So, with that being said, let's get right down to business. Now, so what we're going to do is we're going to look at the images that we took last night, which was for M51. Now, we had IC 405, but for 405 we only got 2 images. They weren't all that great because it was right along the tree line, but we used that to find an object, and we did find it. And I looked at it, got it, which is great. So now, let's get down to business for what we're going to do for M51. So the first thing is we are going to use what's called calibration frames. Now, I've mentioned this earlier in the first few seasons that we had, which was calibration frames and consist of 3 different things. The first one is called a bias frame. Alright, so a bias frame is right here. Look at that, it's amazing. Look at that. When using a CCD or DSLR chip, not all the pixels start out as a value of 0. The purpose of a bias frame is to apply it to a dark and light frame to bring all of the pixels on the CCD to an equal starting value. To make a bias frame, cover the aperture to the corrector plate in the same fashion as the dark frame. Capture at the highest speed or lowest time your camera will allow. So for my DSI, the monochrome camera, the lowest time that I can possibly do is 150 milliseconds. That's the fastest. That's what I did. I took about 23 of them. Okay? And then for the QHY, I did, I think it was like 200 milliseconds, something like that. So I tried to do the best I could. Now, for bias frames, they should be taken at the same temperature and settings as the light frames. With these settings, we can generate what's called a master bias frame. Okay? So that is your bias frame. The next thing is what's called a dark frame. Okay? The purpose of a dark frame is to remove the non-image related thermal and electronic noise that the CCD or DSLR generates when capturing the light frames. It also removes the imperfections of the chip, such as hot pixels. No, not those hot pixels. Since we are capturing the build-up of thermal and electronic noise, it is important to match the dark frame to the same conditions as the light frame. This should include the same duration of exposure, chip, temperature, gain, brightness, and contrast. Dark frames can be taken by covering the telescope. With these dark frames, we can generate what's called a master dark frame. Alright? And then the third but not least is what's called a flat frame. Flat frames are used to address unwanted problems in the optical path, including dirt, dust, vignetting, and internal reflections. Any changes in the optical path, such as focal reducers, filters, camera orientation, or focus, will require a new flat frame. To obtain the best possible flat frame, we would need to take it at the same condition as the light and the dark frame and also the bias frame. To take the flat field frames, first you need to get the scope into focus and then point it to an evenly illuminated surface. Flat field frames can be taken from the twilight sky. What I use is, it's called an artist's sketchboard. It's a flat panel board. And what you do is, like, if you want to do some tracing, it has different settings of light, and I taped it on the wall and had the telescope facing it. I'll post a picture on my Facebook, so this way everyone can look and see how I did it. And then you can adjust the brightness and adjust the contrast, and you'll get it just right. So the exposure time must be chosen in such a way that the intensity level reaches approximately 50% of the maximum. Okay? With these flat frames, we can generate what's called a master flat field frame. So it's pretty easy. That is what's called calibration frames. Now, I took dark frames last night. We have those. Those are all set. I just took bias frames. Those are all set. I have yet to take the flat field frames yet. We can do that, but we'll get that in a minute. Alright? So what we're going to do is we are going to pull up Deep Sky Stacker. Alright? So we are going to pull up the images from last night from M51. Okay, so then the next thing we're going to do is we're going to be getting the images, which as you see here, onto the screen. Alright, so let me take a look at the first one we have here. Alright, so that one was one with the tree, so we're going to get rid of that one. That was the last one we took. I think we had two of them, I think, on here. Okay, no, there was just one. So we had one that just had the tree that was with IC405. So we can actually go through each one individually and actually see them. And they look good. Now, there's going to be a difference in background because that was me, moving the scale around for the levels. But for the most part, these are all in good shape. So everything is good. We can actually move the scale here. Okay. Move this around this way. It gets a little bit brighter. Alright. Find the best one, and then what I'm going to do, looks like according to score that is correct, because I've actually already done this once before. This one seems to be the best one. So then what we're going to do is we are going to use what's called the region of interest and get that just right, and then we're going to use the dark files. Save all of these files. File. Save batch. And then we're going to save these as calibration. Alright. Whoops, wrong button. There they are. So they're saving all of them now. Alright, and these four are going to be the dark frames. Alright. And then I'm going to do the offset bias frames. So you can see up at the top there, the dark frames are there. And again, I have them set in a folder. Bias frames are all going to be right there. We're going to open those, and then those, you can see the bias frames have a different icon. So you can see right here, the icon is completely different. The light frames have like a little dot next to them. And then what we're going to do next is, you won't be able to see it on here, but the next one is what's going to be called register. Right here, there's register picture, check pictures. Okay. So we're first going to click check all. So all of them are going to be checked. And then we're going to do register checked pictures. Alright? And we're going to hit OK. And now it's saving the image. And now it's loading. And it is done. Alright. Now, we get to have fun. Now we get to actually use it and actually figure it out. Now you're going to look at this image and go, well, that's really bright. I don't get it. I don't see anything. I don't see any detail or anything. That's okay. Because now what we're going to do is what we've done in previous processing parties is you're going to do your darkness, your midtone, and your highlight. So we are going to move these and get them all set up. So first off, you have your RGBK levels. Alright, so we're going to move the red channel over. We're going to move the green channel over to get them overlapping. And you can see how there's nothing's like sporadic. It's not like bumpy or anything. It's nice and even all the way across. And that's what you want. And then you go to your three tones, your darkness, midtone, and highlight. And we're going to get that S-curve right between that histogram. And then we're going to bend it just a little bit to get between 5 and 6 degrees. Then you're going to take your darkness, move it all the way down, well, down on the graph, up on the slider. And then your highlights, move it up just a little bit, but you don't want to cut it off too much. Alright, and then you're going to hit apply. Now again, the lines and everything, that will go away in processing. I'm not worried about that at all. My goal right now is to get as much detail on this as possible. There we go. You don't want it to be too grainy. You want the detail to flow. Because I can adjust it in the curves and the levels. That looks good. So now we're going to save it. Alright, so now it's saving. Alright, and now we're going to move right over to Photoshop. I want my... There it is. I was like, where's my action tools? There they are. Alright, so now we're going to create a copy. And the first thing we're going to do is we're going to get rid of the black outline. Because that can play an effect of doing levels. So getting rid of that black outline is extremely smart. Alright. Next thing we're going to do is what's called RC Astro, which is the gradient exterminator. So what that's going to do is it's going to create a level playing field. So this is before, and this is after. Okay? So what it just did was, if you have it like with a bubble effect or anything like that, it makes it nice and even all the way through. Alright? Next thing we're going to do, we're going to make the stars smaller. Done. I'm going to create another copy. Okay. Deep space noise reduction, that's the next one, which is going to get rid of that background. Alright. So it's going to be smooth in the background. Alright. Then you're going to enhance the DSO. This one takes a little bit. This one's got about like 250 steps that it has to go through. So right now, even though you're seeing a checkerboard pattern on there, it is going through each step behind the scenes. And then we'll do less crunchy, more fuzzy. And of course, naturally, there's a lot to play with. There's a lot to do with this. And then I could do levels. And there you have it. And that actually turned out really good. And this one was, again, I forgot to tell everybody last night, I accidentally had the hydrogen alpha filter on this camera. So this is with a hydrogen alpha filter. So detail wasn't as great, and also it was a half moon too on top of that. So, but that turned out really good. I got to admit, that turned out extremely well.